This lesson shows how to graph linear inequalities. The graph of a linear equation is a line. The graph of a linear inequality consists of all the points in the coordinate plane that are solutions to the inequality. This graph is a region called the half plane that is bounded by a line. All points on one side of the boundary line are solutions. All points on the other side are not solutions. For example, if you choose the point 4, 1 in the shaded region above the line and substitute into the inequality, you get 1 is greater than or equal to 1/2 4 minus 3. Now 1/2 4 minus 3 is 2 minus 3, which is -1. And you have 1 is greater than or equal to -1, which is a true statement. So a point in the shaded region above the line is a solution to the inequality. On the other hand, if you choose the point 4, -3 in the region below the line and substitute into the inequality, you get -3 is greater than or equal to 1/2 4 minus 3. This simplifies to -3 is greater than or equal to -1, which is a false statement. So a point in the unshaded region below the line is not a solution to the inequality. To graph a linear inequality, begin by graphing the boundary line. Replace the inequality symbol with an equal sign, and you have the equation of the boundary line. If the inequality includes the or equal to phrase, graph a solid line to indicate the graph includes points on the line. If the inequality does not include the or equal to phrase, graph a dotted or dashed line to indicate the graph does not include points on the line. Next, if the inequality is greater than, shade above the boundary line. This means that all points above the boundary line are solutions to the inequality. If the inequality is less than, shade below the line. This means that all points below the boundary line are solutions to the inequality. If the boundary line is steep, it can be difficult to decide which side of the line is above or below. For this example, the right side of the line is above the line, because if you choose a point on the right, you can go upwards without crossing the line. On the other hand, if you choose a point on the left and move upwards, you would eventually have to cross the line, since it is tilted slightly to the left. So the left side of the line is below the line. Here's an example of an inequality with a boundary line at y equals -3x plus 3. The region above the line is on the right, and the region below the line is on the left. For inequalities with horizontal boundary lines, the shading is pretty simple. For less than inequalities, shade below the line. For greater than inequalities, shade above the line. For vertical boundary lines, shade to the right for greater than inequalities, and shade to the left for less than inequalities. Here's an example that shows all the steps for graphing and checking a linear inequality. The first step is to convert the inequality to slope-intercept form. Begin by subtracting x from both sides. Then divide both sides by -2. Remember, when you divide both sides of an inequality by a negative number, you have to switch the direction of the inequality symbol. On the right, when you divide -x by -2, you get plus 1/2 x. When you divide -2 by -2, you get plus 1. And the result is y greater than or equal to 1/2 x plus 1. Next, graph the boundary line y equals 1/2 x plus 1. Then, since the inequality is greater than, shade above the line. Now do a boundary check. This verifies you have correctly graphed the boundary line. Select a point on the line like 2, 2. Change the inequality to an equation and substitute x equal 2 and y equals 2. Simplify the expression, and you can see the boundary check. Finally, do an inequality check. This verifies the direction of the inequality symbol. Select a convenient point in the shaded region, like 0, 2. Substitute x equals 0 and y equals 2 into the inequality, and simplify. You get -4 is less than or equal to -2, and the inequality checks. This lesson showed how to graph linear inequalities. This lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.